our last lesson, we talked about lines. And the two general equations for a line, y equals mx plus b, and y minus y1 equals m times x minus x1. So the two general equations of a line. So today we're going to do a little bit more exploration of lines. We're going to look at horizontal, vertical, parallel, and perpendicular lines. So there's just an important note that's repeated from the last lesson. Remember, if you see the word function, just think equation. And if you see these unfamiliar symbols, f parentheses x, g parentheses x, just replace those with y. They just mean y. So for example, if you see, consider the function f of x equals 3x minus 2, you would just say, oh, that means consider the equation y equals 3x minus 2. All right, so jumping into today's lesson, I've got 3 points, 7, 2, negative 4, 2, and 0, 2. I'm just going to plot those 3 points. So 7, 2 means right 7 up 2. Negative 4, 2 means left 4 up 2. And 0, 2 means I don't go left or right, and I just go up 2. So there's my 3 points. If I connect these 3 points with a line, what kind of word can you use to describe that line? Horizontal. Good. All right, so I want to write an equation for the line that goes through these points. So all 3 points have something in common, right? They've got this in common. They all are something, comma, 2. Which coordinate is it that they all have in common? The y. The y coordinate is always 2. So that's the equation of your line. Y is 2. Every point on that line has a y coordinate of 2. So its equation is y equals 2. Let's calculate the slope of the line. If I want to calculate the slope, I can pick any 2 points on the line, pick any 2 points and calculate its slope. It'll always come out the same. So let's look at these first two, 7, 2 and negative 4, 2. So slope, we characterize it with an m. It's our change in y over our change in x. So I'm going to subtract the y coordinates. So it's going to be 2 minus 2 over 7 minus negative 4. 2 minus 2 is 0. 7 minus negative 4 is 11. What's 0 over 11? 0. So horizontal lines have equations that look like y equals a number, right? Because they're always going to share a y coordinate. And they have a slope of 0. All right, let's look at another example here. Always have a slope of 0, yep. Right. Yeah, you can do it in either order. So if I do this one minus this one for when I do the y's, then when I do the x's, I should do this one minus this one. So as long as you go consistently, it doesn't matter which one's x1, y1, and which one's x2, y2. All right, let's look at a similar example. I've got the points 4, 2, 4, 5, and 4, negative 3. I'm going to plot them all. So 4, 2 is right 4, up 2. 4, 5, right 4, up 5. And 4, negative 3, right 4, down 3. If I connect those 3 points with a line, what kind of word can I use to describe that line? Vertical. So if I want to write an equation for that line, I think about what every point on this line has in common, right? They've got the 4 as the x coordinate. So that's its equation. X is 4. X equals 4 is the equation of that line because every point on that line has an x coordinate of 4. All right, so if I want to calculate the slope, I can pick any 2 points I want. I'll just pick the first 2. And I calculate its slope by change in y over change in x. So I subtract the y coordinates. I'll do 5 minus 2. Right, so if I did 5 minus 2, then I got to do 4 minus 4 to the bottom. So that's 3 over 0. What is 3 over 0? Ooh, I got a couple different answers. I heard 0, I heard 3. Undefined. It's undefined. This is an undefined amount. You can't divide by 0. Exactly. So if you've never seen y, I'm going to do a quick justification of why you can't divide by 0. So you had 3 divided by 0, right? I heard some people think that the answer was 3, right? So let's see. If it was 3, then 3 over 0 would have to equal 3 over 1. Does that seem like those two quantities should be the same? No. And if you know anything about, if you've ever seen cross multiplying, right? If you multiply your fraction, the upper right and lower left, you get 3 times 0 equals 3 times 1, right? Which is not true, right? So you can't do that. So 3 over 0 is definitely not 3. If I try to make it 0, right, and I do that cross multiplying trick that says that 3 times 1 has to equal 0 times 0, which is also not true, right? So we can't divide division by 0. There's no answer that's going to give you a statement that makes sense, right? So we just say you can't do it. Ignore division by 0. We call that undefined. All right, so our big conclusion for vertical lines is that they always have an equation of the form x equals a number, and their slope is always undefined. So to review, horizontal line, its equation looks like y equals a number, and the slope of horizontal lines is 0. Vertical lines have equations x equals a number, and the slope of every vertical line is undefined. Okay, so the thought process, if you want to find an equation for a vertical or a horizontal line, okay, to find the line that has undefined slope and passes through the point 5, -7, we would say, okay, if it has undefined slope, it's vertical, right? If they tell you the slope is undefined, you know it's a vertical line. So vertical lines have the form x equals a number. So to figure out what that number is, we just look at the point 5, -7, and I want to know what x equals, so I pick the x coordinate. So the equation of that line would be x equals 5. All right, let's do a similar exercise, but this time we have the equation of a line that has a slope of 0, and it passes through the point 3, 2. So slope of 0, horizontal or vertical? Horizontal, right. So this is a horizontal line, right? And horizontal lines have the form y equals some number, right? And the question is, what should that number be? So you look at the point 3, 2. I'm looking for y equals a number. So what's the y coordinate of that point? 2. So y equals 2 is the equation of the line I'm looking for. Okay, I have graphed 3 lines over here. They appear to be parallel, meaning they never intersect and they're always equally distanced apart. And I have their equations, each line is labeled with its equation. And what number in each of these equations represents the slope? The 2, yeah, it's the coefficient on the x. This 2, and this 2 represents the slope of each line. So all 3 of those lines have the same slope. Okay, so we conclude that 2 lines are parallel if their slopes are the same. If their slopes are equal, that means the lines are parallel. If the lines are parallel, that means their slopes are equal. So we've dealt with parallel lines. Let's look at perpendicular lines. So I've got two perpendicular lines here. And I'm going to find the slope of each of them and see if they have any kind of special relationship. Parallel lines have the same slope. I want to compare the slopes of these two lines. So I have to pick, let's label this line 1, and this one will be line 2. So let's work on line 1. I have to pick nice points on line 1. I've got 0, 4. And maybe right there looks like -1, -1. Is it clearer on your graph? -1, -1, great. Okay, so I've got 2 points on line 1. I want to find the slope. So I'm going to label this m sub 1 to mean the slope of line 1. Okay. So slope is change in y over change in x. Okay. So I'm going to subtract the y's. 4 minus -1 over 0 minus -1. So that comes out to 5 over 1, which more simply could be written as 5. Good. All right, so I've got the slope of line 1. Now I'm going to look at the slope of line 2. We'll do this one in a different color. So this is line 2. Looks like 5, -4 is a point on that line, and maybe 0, -3 is a point on that line. So I'm just picking nice grid points where it crosses. And I'm going to find the slope of line 2. I'll call it m sub 2 to be the slope of line 2. Change in y over change in x. So my y is -4 minus -3. Subtract the y's, and then subtract the x's, 5 minus 0. So -4 minus -3 is -4 plus 3, which is -1. 5 minus 0 is 5. Do you see a relationship between the number 5 over 1 and the number -1 over 5? Yeah, so we call them reciprocals, right? When you flip a fraction over, we call that its reciprocal. So 1/5 and 5 over 1 are reciprocals. And these two numbers are also opposites, meaning one is positive and one is negative. So perpendicular lines have opposite reciprocal slopes. Opposite meaning one's positive and one's negative. Reciprocal meaning you flip the fraction over. Right, any questions? So we did 4 really key things in this lesson: horizontal lines, vertical lines, parallel lines, and perpendicular lines. And now I'm going to have you move to the activities and do some practice with these things. Sure. Okay, so the directions say find the equation of a line with the given conditions. So if they ask for the equation of a line, you're trying to find y equals mx plus b. And you need a number for m and you need a number for b. So you start by writing down y equals mx plus b. Your goal is to replace the m and the b with a number. Okay? So m is the slope, and they told me that the slope is -2. Right? So I'm going to replace my m with a -2. And then b is the y-intercept, which they told me is 11. So I replace my b with an 11. So that's the first one. Y equals -2x plus 11. That's slope-intercept form, yep. Because m is slope and b is the intercept. Slope-intercept form, that's why it's called that. And then that's it. You're just looking for that equation. All right, so if I want to do a line through 2 points, this is a little bit different because they didn't just tell me the slope. I'm going to have to calculate the slope. So I'm going to start by calculating slope, change in y over change in x. Subtract the y's, -6 minus 9, over subtract the x's, 0 minus 3. Okay. So -6 minus 9 is -15. 0 minus 3 is -3. Negative over negative is going to make a positive, and 15 over 3 is 5. So that's my slope. So now when I write down y equals mx plus b, I can replace the m with a 5. Y equals 5x plus b. Now I want to replace the b with something. Okay, if they didn't come right out and tell me what the y-intercept is, and I can pick a point, right? Pick either point. Like maybe I'll pick 3, 9. 3 is an x-coordinate, 9 is a y-coordinate. So you go over to your equation, you replace the y with the 9, the y-coordinate. Replace the x with the x-coordinate, 3. And you can use either of your points, doesn't matter what point, plus b. And then you solve for the b. So if I subtract 15 from both sides here, I get b is -6. So my final answer is going to be y equals 5x minus 6. Right? I replaced the m with a 5 and the b with a -6. Yes, so you might have noticed, like Xiomara just pointed out, the x coordinate that I was given, the x coordinate that I was given was 0, -6, right? The hallmark of a point on the y-axis is that its x-coordinate is 0. So if you're given a point that has an x-coordinate of 0, you know that's your y-intercept, because this is on the y-axis. If you plot that point, it's on the y-axis. Right? So we could have identified that as the y-intercept right away and just put the -6 in. Okay. But I wanted to do it the other way, just to give you another tool in the event that they didn't tell you the y-intercept. You can pick any point, plug it in for x and for y, and solve for the y-intercept. All right, so I think that should be enough review to have you work through a couple more. Okay, let's go through the quick check. So we want the equation of a line in slope-intercept form. So I'm looking for something that has the form y equals mx plus b. I want to replace m and b with numbers. M is the slope of the line, right? So I have to calculate the slope of this line. And in order to calculate slope, what do I need? Rise over run, 2 points, right? So I gave you 2 really nice grid points here and here. So there's sort of 2 ways you can do it. This one is 0, 14, and this point is -6, 0. So you could calculate the slope by subtracting the y's, 14 minus 0 over 0 minus -6, which is 14 over 6. And if you want to reduce that, that's fine. That's the same thing as 7/3, right? Or some people like to do it graphically. If you draw a triangle, right, the rise of the triangle is 14, and the run has a length of 6. Right? So rise over run would be 14 over 6. All right, so I know the slope. So I come to my line and I replace m with 7/3. Just made one substitution, replacing the m with a 7/3. And if you left it as 14 over 6, don't even worry about it if you didn't reduce it, because they are the exact same value. All right, now b represents the y-intercept. Can you tell the y-intercept just by looking at the line? What is it? 14. The y-intercept is the place where it crosses the y-axis. So if I have a picture, I can just look at where it crosses the y-axis, and that's my b. That's the final answer. I saw lots of people trying to use the plug in a point method to figure out B, which will also give you the correct answer, with just an algebraic way of doing the question rather than a graphical way of doing the question. So you can look at the graph and just pick out the y-intercept. But if you like the algebraic way, I'm just going to do it really quickly underneath here. So if I have y equals 7/3 x plus b, pick any point on your line. I could pick 0, 14 or -6, 0. Plug in the x coordinate for x and the y coordinate for y and solve for b. So let's plug in -6, 0. So I put in 0 for y, okay, -6 for x, and I can solve for b, right? 7/3 times -6, you could throw it in your calculator, or you could recognize that that -6 over the 3 reduces to -2, and you get 0 equals -14 plus b. Add 14 to both sides, and you get b is 14, which is exactly what we got when we just looked at the graph. We saw that the y-intercept was 14. So then we would come back up to our equation, y equals 7/3 x plus 14. So you get the same answer either way. You can always go to that algebraic method if it wasn't given to you what the y-intercept is. Even if it is, the algebraic method will still work. Questions? All right, so let's look at the beginning of lesson 8 here. So we're just going to continue our theme of working with lines. And today, in this lesson, we're going to look at lines of best fit. So we're going to look at some real life data and explore how to use a line of best fit to characterize that data. So in 1982, drunk drivers were responsible for 25,165 deaths in car accidents, and that was 57.3% of all fatalities due to car accidents. And this table shows the percentages of fatalities due to drunk driving in several different years. So 1982, drunk drivers were responsible for 57% of car accident fatalities. 1985, 51%. 88, 50%. So the general trend is downward, right? All right, so this data came from the National Highway Traffic Safety. All right, so if I wanted to display this data from the table in a graph, I could treat these like points. This could be 1982, 57, 1985, 51. But 1985, 1982, those are like big numbers. That's 1,982. So instead, I'm going to treat 1980 like year 0, right? So 1982 is going to be year 2, 85 is year 5. It just makes it so that I can have smaller numbers on the x-axis here. So on the x-axis is going to be year, on the y-axis is percent fatalities. Now, what are the coordinates of this point? We'll call it point A. 8, 50, right? You go over 8, up 50 to get to that point. Okay, and what about this point on the very end here, point B? Yeah, 1938. It's harder to estimate because it's not right on a grid line, right? So what I could do is go back up to my table and say it's this point, right? 1999, how many years after 1980 is that? 19. So that point is 19, 37. Right? Because every point on this scatter plot, this is called a scatter plot, corresponds to the data, something in the data table. So that point is 19, 37. Okay, does the scatter plot show any relationship, pattern, or trend between these two variables? Yeah, it shows that we have a decreasing trend. As years go on, the percent fatalities due to drunk drivers is going down. Okay, so we have a decreasing relationship. The data appears to be decreasing. So it's just a nice visual, like you might have noticed it when you just looked at the table of values, but we have this really nice visual when you plot them that shows a decreasing line. Okay, so I'd like to sketch a line that looks like it best fits the data. Okay, so I want to draw a line that comes as close as possible to all of the points. It might not hit all of them, but I want it to be as close to all of them as possible. So something like, maybe something like that. Right, so some are above and some are below, and sort of an equal amount above and below. Some might be right on it. So we call that thing a fit line or a best fit line. Okay. The data in the scatter plot appear to be roughly linear, so we sketch a line that comes close to all the data points. So T and P are approximately linearly related or linearly associated. T is going to represent time for year, P represents percentage, right? So instead of X and Y, I'm using T and P because these are representing real things. And using T and P like reminds me of what they represent. So of all the lines that we could draw near the points, the very best line that I drew, which is the one I drew right here, has a name. And we call the line of best fit, or the least squares regression line, or more simply, the regression line. Finding the actual line of best fit is something that calculators and computers can do. And if you take a statistics course next, you'll be able to do it also. When we draw a line of best fit, we're just going to eyeball it, right? We're not going to be doing exact calculations to figure out where it is. We're going to eyeball it to approximate the line of best fit. Okay, so we can use this line, the line of best fit, to make predictions about the data. So I want to use the line of best fit to predict the percentage of fatalities due to drunk driving in 1993. Right, so I go up to my picture. 1993 is what number on the x-axis corresponds to 1993? 13, right, because we started in 1980. So at 13, I don't have a data point for my actual data table for 1993. I don't have a 13, but I can use my line to estimate what that percentage is. So I find in my year data 13, I go up to my line, right, and I need to know the y coordinate of that point. So I go over to the y-axis, and it looks like the y coordinate would be something like 44, sure, 44. So that point looks like 13, 44. So my line of best fit predicts or estimates, right, that the percentage of drunk driving fatalities in 1993 is approximately 44%. So the line was useful because I didn't have data for 1993, right? I jumped from 1991 to 1994, so I used the line of best fit to predict what happened in 1993. All right, so using the graph of the line, we're going to pick 2 points that have nice coordinates. So we are picking points on the line, even though these points will likely not be in your original data points. I want to find the equation of the best fit line that I drew. So if you go up to the picture, I want to pick points on the line. So for example, 16, 40. 16, 40, that point looks like it's on the line. So I'm going to use 16, 40. It's not one of my original data points, but it does fall on my line that I drew. It looks like a best fit line. And then also 20, 35. 20, 35 looks like it's on my line. 20, 35. So you want to pick points that are on your line. They don't have to be your original data points. Okay, if one of your original data points does happen to fall right on your line, then you can use it. Otherwise, pick points on the line itself. Okay, so I've picked 2 points, 16, 40, and 20, 35. Those are 2 points on my line of best fit. So using those points, I want to find the equation of the regression line, the equation of the line of best fit. Right? So the equation of a line of best fit, first step is to find the slope. Slope is change in y over change in x. But I'm not using y and x, right? I'm using t and p, time and percentage. So this is actually going to be change in p over change in t. All right, so I'm going to subtract my p's, 35 minus 40, over my change in t. So subtract my t's, 20 minus 16. So 30 minus 40 is -5, 20 minus 16 is 4. So -5/4, which you could reduce if you wanted to -1.25. You could change it to a decimal, or you can leave it as -5/4. Doesn't matter. And if I want to find the equation of my line, I start with y equals mx plus b, general equation of a line, as long as it's not vertical, right? It's y equals mx plus b. I now know the slope, because I found that in the previous line, so I replace the m with -1.25. And now I just need the y-intercept. I could try to estimate it from my picture. Right, looks like, ooh, it's hard to say, 58 maybe. Yeah, something like that. But because it's hard to estimate, it doesn't go right through a grid line. Let's do it the algebraic way. Pick one of the 2 points, plug it in, and solve for b. So I can pick any point I want. I'll pick 20, 35. So I put 35 in for y, 20 in for x, and then b is my only unknown, and I solve for b, which will be the y-intercept. Okay, so 1 1/4 times 20, 25, -25. So 35 equals -25 plus b. And then add 25 to both sides, and I get 60 equals b. So the final equation of my line, go back to where I didn't know what b was. Now I know what b is, so I put it in. -1.25x plus 60. Oh, and I told you to use t and p and not x and y, right? So x is actually time in this case, use t, and y is percentage of fatalities. So I'm totally fine with it if you do everything in terms of x and y and then change it to the variable names at the end if you want. That helps you keep things straight. All right, so p is -1.25t plus 60. I'm going to rewrite it here. All right, so in this case, we can figure out how accurate we were when we picked nice points on the line, right? If you have a computer find the line of best fit, it comes out to -1.19x plus 58.63. How far were we off based on the points we picked? Not too bad, right? Our slope was really close. Y-intercept is off by like 1.5-ish. Yeah, so we were really close. So using sort of an eyeball approach is really not that much worse than letting a computer do it. All right, so now I want to use my equation, right? Instead of just looking at the line like I did before, I want to use my equation to predict the percentage of fatalities in 1993. So several questions ago in 4B, I just looked at the line. I said, oh, 1993 is here. Y coordinate looks like it's about 44, right? So now I can be a little more accurate because I have an equation. So I would like to know percentage. So I'm trying to get P. 1993, you told me earlier, was 13. So I'm going to put a 13 in for T. So P is negative 1.25 times 13 plus 60. Now I need a calculator. .25. Oops. Why isn't this working? Because I'm holding this. Yeah. Thank you. 1 point. Oh. Yep. I'm just going to open it again. There we go. Still doing it. So 1.25 negative times 13 plus 60 is 43.75. So 43.75%, right, is our prediction when we used an equation rather than just looking at the graph. So our eyeball approach was, again, pretty accurate. It was only off by 0.25%. So like I said before, this was handy. It was a handy tool because I didn't have a data point for 1993. So I can use my line to predict what might have happened in 1993 based on the trend. Okay. And because 1993 was between 1982 and 1999, which is the starting and ending point of my data, we call that interpolation. Inter meaning between, right? The base of it being inter, which is between. So 1993 was between the data I was given, so we call that interpolation, when you make an estimate or a prediction between the given data. Now I'm going to use my regression line to predict the percentage of fatalities due to drunk driving in 2002. So how many years after 1980 is 2002? 22 years. So I'm going to use my line, P equals negative 1.25, and this time I'm going to plug in 22 for T, for 22 years after 1980. So 1.25 negative times 22 plus 60 is 32.5%. So this is called extrapolation, right? When you go beyond your data, when you use your formula or your regression line to make a prediction for data that is past or before the data you were given, right? So my data ended at 1999, and I just made a prediction for 2002 and past the data I was given. So we call that extrapolation, extra beyond the data. Okay. All right, any questions? So the process we're dealing with here is really similar to what we did in the last class. It's just we're doing a line of best fit, but you do the same process. You pick 2 points, find the equation, just like you were doing before. It's just that you have to pick the points on the best fit line rather than having them given. All right, so we've got about 15 minutes. You can, I'd like you to start the activities for this lesson.